As you begin this electrical versus gravitational potential assignment, we look in this part one. Here we're looking at gravitational potential, and we are asked about the situation with a book, and this book is on the floor, and so really we're focusing on gravitational potential. And then what it is asking over here is giving us this question here saying about the amount of force, a calculation for the amount of force, and then looking at the calculations, the factors determining the size of this. So the factors that determine the size of the force is mass and gravitational field strength. So we have mass and gravitational field strength, M and G. So we already have that, we know this, and so there's nothing you need to type in this explanation. As I continue looking, mass, gravitational field strength, and the change in height is what affects this gravitational potential energy. We can see it in the equation, mass, M, G, that's the gravitational field strength, and the change in height, mgh. This is all stuff that we had in the first quarter that we worked together. Then as I look at this gravitational potential, now we're looking at this gravitational potential energy per unit mass. So it takes that change in potential and divides out the mass. And so what we are able to see when we look at these calculations, what it depends on is the gravitational field strength and the change in height. That this now does not depend on mass. So this talks about the gravitational energy per unit mass. If we put in a certain amount of mass, then we know how much energy it has at a certain height. That's what we're getting to. And so then it says here, how does this gravitational potential differ from gravitational potential energy? And so it just states what it is. There's nothing you need to do here for this first part. The second part, this is where now we're dealing with charges. You have a negative plate and a positive plate. There is an electrical field between those two. It's given here as this approximate 10 newtons per coulomb or 10 volts per meter. Both are units for this electrical field. We have the two charges, a 2 microcoulomb and a 1 microcoulomb, object 1 and object 2. And they're separated here by a distance of 2 meters. So with this, then we are asked about calculating the force. Just like with the gravitational force, which was mass times gravitational field, we have this Q times E. So this calculation here, the factors that are going to determine the size are going to be found in this equation. So I want you to use that part one to help you answer these questions down here. Obviously, noting the difference is now that we're working with an electrical field as opposed to a gravitational field. So what factors go into this electrical force? So it's going to be just like how when we looked at the gravitational force, it had mass and gravitational field. Now we're dealing with charge, Q, and electrical field, E. So we have charge and electrical field. Those are the two components that will determine the size. As we look down to this electrical potential energy, now we have to look at all the factors going in here. What is Q, what is E, and what is D? Once again, I will ask that you refer back to this part one that we have to help guide you. And then calculating this electrical potential energy. Once again, this is showing the calculations. I just want you to tell me what factors determine the size of this difference. And then, how does electrical potential differ from this potential energy? I continue. I look here. I have a similar situation. Now it's different. We have a different electrical field, 22 newtons per coulomb. We also have different charges. And with this, now we have charge 1, charge 2. Charge 1, I give you the calculation to find that electrical force on the first charge, given the charge and the electrical field strength. I want you to type in your answer here telling me the electrical force on charge 2 being the 5 microcoulomb charge. Charge 2 being the 5 microcoulomb charge, now I want you to calculate the electrical potential energy. I show you how to do it for charge 1. Then continuing on, I want to know the difference in this electrical potential. Now that's the potential energy per unit charge. I want you to show me the calculation. And then in this explanation, I want you to tell me the factors that determine the size and for both the potential energy, and as well as the electrical force. Make sure you have all the white boxes in this fully complete, and you are done. Thank you.